In this video, we will be discussing units of concentration and some calculations. Now, we're all familiar with molarity and percent by mass, and some of you may be familiar with mole fraction, but today we're going to introduce a new unit of concentration, molality. But first, a little review over molarity. Molarity, as you recall, is moles of solute over liters of solution. Specifically solution, not solvent, because sometimes volumes are not additive. And molarity was very useful for stoichiometry. On the other hand, molality is moles of solute over mass of solvent, or more specifically, kilograms of solvent. Now, molality is very important because it does not vary with temperature, and it is very useful for calculations involving colligative properties. So, for example, we want to calculate the molality of 0.5512 grams of glucose dissolved in 58.5141 grams of water. Well, we just need two things. We need the moles of the solute, and we need the mass of the solvent. Moles is easy. We take the mass of glucose divided by the molar mass of glucose. But when it comes to the solvent, we have to be very careful. We have to identify what the solvent is, and then we need to take its mass and make sure it's in kilograms. In this case, we have to convert grams of water to kilograms of water. And those are the only two values we need in order to calculate molality. Now, the unit for molality is the lowercase italicized m, if you're ever looking for it. Now, mole fraction looks a little familiar. Familiar with percent by mass, which is the mass of the constituent of the mixture or the compound that we're interested in, divided by the total mass times 100. Mole fraction is very specific to moles, so we have the number of moles of the component of a mixture or a solution that we're interested in, divided by the total number of moles that are present. But we're not multiplying it times 100. And it's very important to note that mole fraction is unitless. It is moles divided by moles, so it has no units at all. So an example, we have a solution that contains 75 moles of glucose dissolved in 225 moles of water. If we want to know the mole fraction of glucose, well, we just take the moles of glucose and divide it by the sum of the moles of both the solute and the solvent, and any other components that might be present in this solution. And we get an answer of 0.250, no units. Now, with this information, what do we do if we want to calculate the mole fraction of water in this solution? So sometimes we want to calculate the mole fraction of the solvent, and sometimes we want to calculate the mole fraction of the solute. Well, there's two ways we can do this. We can either take the number of moles of the water, divide it by the number of moles total, and we get our answer of 0.750. Or if you look at that number, you notice that we could just take 1, which is the total fraction of everything, and we can just subtract the mole fraction of glucose that we calculated earlier from 1, and that'll give us the same answer. So there are two ways to calculate the answer of the other component in the solution. Now, one of the more interesting calculations that we can perform is converting percent by mass to molarity and then later on molality. So for example, we have rubbing alcohol, which is 71% by mass isopropyl alcohol in water, and the density of a solution at this percentage is 0.848 grams per milliliter. Now, it's very important that we have that density. We can't do these calculations without density. First, we want to calculate the molarity of this solution of isopropanol. Well, we need to know the number of moles of alcohol and the total volume of solution. We haven't been given that information. So here's the trick. Assume you have exactly 1 liter of solution. If you have 1 liter, you can use the density to determine the mass of that solution. And this is a mixture, the whole thing. And then once you have the mass of the solution, you can use the percent by mass to determine how much isopropanol is present. So first off, well, our density is in grams per milliliter, so we need to convert our liters to milliliters, so that's 1,000 milliliters, and so we have 848 grams of solution total. So now that we have that 848 grams, we're going to use the percent by mass to find out how much of that 848 grams is actually isopropanol. And so we just multiply our mass times our percentage divided by 100, and that gives us our mass of isopropanol. Now that we have mass of something, we can easily convert it to moles. So, using the molar mass of isopropanol, we're going to divide the mass by the molar mass, and this tells us we have 10 moles of isopropanol in 1 liter of solution. Well, what's molarity but moles per liter? So we have 10.0 molar. Next, we're going to calculate the molality of solution. Now we need to find the number of moles of alcohol and divide it by the kilograms of water. Oh, well, we've already calculated the moles of alcohol from the previous example. We're going to, again, assume we have exactly 1 liter of solution. Again, we're going to use the density to determine the mass, and then the percent by mass to find the mass of isopropanol, which we've already done. And then we have to find out the mass of the solvent. Well, that's going to be whatever's left after we determine the mass of the isopropanol. So, from the previous calculation, 1 liter of solution, well, that's 848 grams of solution. Mass of just the isopropanol at 602.08 grams. So the mass of water, well, that's just the total mass, the 848 grams, minus the mass of isopropanol. And so we have 245.92 grams of water, or 0.24592 kilograms. And there we go. We know our number of moles from the previous calculation, and we have a 40.74 molal solution.